Dear mathematicians, in this short video, we're going to be looking at hypothesis testing. So we are having a question, assuming that the product moment correction coefficient of any data is 0.774 and n is equal to 8, the number of observations is 8, the level of significance is 5%, and we are talking about data that is from the number of hours spent reading against the scores obtained. So the number of hours is X, then the scores obtained is Y. So here is a claim. There is a positive correlation between hours of reading and the scores obtained. Then we are required to carry out a hypothesis test to check the claim. Solution, we shall first state the null hypothesis. So we state the null hypothesis because we are told that the claim that is there is there is a positive correlation between hours of reading and the scores obtained. So this tells us that this is a one-tailed test. A one-tailed test because we are talking about positive correlation, meaning the product moment correlation coefficient has to be greater than 0. So the null hypothesis always, when we are dealing with the product moment correlation coefficient, is always equal to 0, meaning there is no correlation between the two variables x and y. Then the alternative hypothesis is the one now that is obtained from the claim. So it is greater than 0, implying there is a positive correlation. So from there, we need to draw the distribution curve. So when you draw the distribution curve, the center is at 0, and then you need to look at the level of confidence, level of significance. The level of significance is 0.05, representing 95 confidence interval. So that means this above this is a rejection region. So what we do, we go to the table, and read off the critical value. So let's go to the table, go to 8, which is the number of observations. Then under one-tailed test, check for the 5% significance level, which is representing 0.05 level of significance. So below that, you go to 8, and the value is 0.6215. So that means the critical value is 0.6215. But what is the calculated value? So let's name this. This is what is called the rejection region. If we find a value that is within this region, then we reject the null hypothesis. If it is within here, we fail to reject the null hypothesis. Okay, so if the calculated value is 0.774, then that means it is within. So if it was less than this value, then it would be in the it would be outside the rejection region. But if it is above 0.6215, then it is going to be in the rejection region. So it is within the rejection region, and therefore we reject the null hypothesis. So what is the conclusion? There is sufficient or enough evidence to suggest that there is a positive correlation between the number of hours of reading and the scores obtained. Very, very, very good. So in summary, once you're given a data, you might need to calculate the PMCC, but in this question, in this problem, the PMCC was given. But if it is not given and you're given values of x and y, then that PMCC row would be obtained from first of all sum of x minus x bar times y minus y bar. Then you divide by square root of sum of x minus x bar squared times sum of y minus y bar, this value is squared. Then you take their square root, then you calculate for that row. So the moment you get it, then you consider the n, which is the number of observations of the sample, the significance level, and then you look at the claim. So the claim here is a positive correlation coefficient, meaning it has to be this value has to be greater than 0. So it is one-tailed test. You draw your distribution curve, then you go to the table, get the critical value, and determine whether the calculated value is within the rejection region or not. If it is within the rejection region, then we reject the null hypothesis, and the conclusion is there is enough evidence to suggest that there is a positive correlation between the number of hours of reading and the scores. Ladies and gentlemen, we are told that given 10% significance level, n is equal to 8, the calculated value of PMCC is negative 0.716. We are told to to test the claim, which says that there is a negative correlation between x and y. So this is the product moment correlation coefficient that was obtained by calculating the Pearson's product moment correlation coefficient between x and y values. So we have to carry out the hypothesis test to check the claim. Again, the claim is saying a negative correlation between x and y. So we need to look at the hypothesis. So one, we need to state the null hypothesis, whereby rho is equal to 0, so no correlation. Then the alternative hypothesis, rho is less than 0, because we are told that we have a negative correlation according to the claim. It is the claim that gives us the alternative hypothesis. Good, so we proceed and draw the normal distribution curve. So this basically tells you that we are talking about a one-tailed test. So these are the tails. So the one-tailed test in the negative direction. So 0 is here, and this is alpha 0.1. So the remaining area represents 90% confidence interval. So we need to get the critical value at this point that corresponds to n. So we need the critical value that corresponds to alpha equal to 10, and then n is equal to 8, the number of observations. So we shall just go to our table and look for 8 and the one-tailed test. Then we go to 10. Okay, go to 8, then move along, pick a value below the column of the significance level. So this would give you 0.5067. So we have 0.507. So we have negative 0.5067. If the values are this side, then you put a negative. Yeah, so let's go to our value. the calculated value is negative 0.716. So you realize the calculated value is 0.716 negative. So it's within the rejection region. So you can say the calculated value of PMCC, the product moment correction coefficient, is within the rejection region. So if it is within the rejection region, you reject the null hypothesis. So if you reject the null hypothesis, what happens? Then there is evidence. There is evidence that there is some sufficient evidence that if we say there is sufficient evidence, okay, sufficient evidence to suggest that there is a negative correlation between x and y, because if let me say here, we said the null hypothesis, there is no, and if the value that you obtain is within the rejection region, then we are supposed to reject the null hypothesis. So if we find that the null hypothesis is rejected, then there is evidence suggests that there is a negative correlation. So here we are supposed actually to take it is supposed to be there is evidence. There is enough evidence to suggest that there is a positive correlation between the number of hours of reading and scores. Likewise here, if we reject the null hypothesis, then conclusion we shall say there is sufficient evidence to suggest that there is a negative correlation between x and y. Maybe we need to do one lastly so that we can check. Okay, sometimes you may find that there is no sufficient evidence. So could you maybe just do one and see? So if, for example, here, if rho is 0.6, maybe 0, then alpha is 8. No. Alpha is 5. The first one, the one we used up here. Yeah, alpha is 5. Let's use that. So alpha is 5%. And then n is equal to 8. Remember, we already said that the critical value, this is from table, is 0.6215 from the table. So let me draw our curve. So we said that this is for the null hypothesis, rho is equal to 0, and the alternative hypothesis, rho is greater than 0. So we are doing a check for this. So that means 0 is around here, and the critical value is around there, 0.6215, and alpha is 0.05. So you can see that the calculated value is outside the rejection region. So P calculated, rho calculated is 0.600, and outside the rejection region. So if it is outside the rejection region, we fail to reject the null hypothesis. Conclusion that we are supposed to give shall say there is no sufficient evidence to suggest that there is correlation between x and y values. That is if we consider the x and y values here. So we have looked at the three cases. There could be more, but majorly we have looked at a positive correlation and where we have negative correlation and where we reject the null hypothesis that says there is no correlation. And then there is a case where we have found out that the calculated value is outside the rejection region. And therefore, we have realized that here we fail to reject the null hypothesis. And then the conclusion is that there is no sufficient evidence to suggest that there is a correlation between X and Y values.